Hello everyone. So today we will study about the chemical bonding and molecular structure in detail. So let's start. First disclaimer slide which says the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathi@itk.ac.in and we shall remove the images. Moving on to our question number first. So, among the following, electron deficient molecule is. Options are CCl4, PCl5, BF3, and SF6. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option number C. So how? Let's see. The compounds in which the central atom has less than 8 electrons in their valence shell are electron deficient. So in the option number A, CCl4 is given. So this is the structure of CCl4 and carbon is the central atom here which has 8 electrons in the valence shell. 4 from carbon and 1 electron each from 4 chlorine atoms. So it is not electron deficient. Second option is PCl5. So this is the structure of PCl5 and phosphorus here is the central atom having 10 electrons in valence shell. 5 from the phosphorus and 1 each from the 5 attached chlorine atoms. So it is also not the electron deficient molecule. Option number C is BF3 and this is the structure of BF3 and boron here is the central atom having 6 electrons in the valence shell. 3 from boron and 1 each from the 3 fluorine atom attached to it. So boron in BF3 has less than 8 electrons as it has only 6 electrons. So it is electron deficient molecule. And if you see in option number D, SF6 molecule, this is the structure of SF6 molecule and sulfur is the central atom here having 12 electrons in the valence shell and 6 from the sulfur and 1 each from 6 fluorine atoms attached to it. So it is also not the electron deficient. Hence, the correct option will be the C option, that is BF3. Okay, so moving on to our next question, question number 2. Sodium chloride is soluble in water but not in benzene because options are the delta H of hydration is less than del H of lattice energy in water. Del H of hydration is greater than del H of lattice energy in water. Del H of hydration is equal to del H of lattice energy in water, or del H of hydration is less than del H of lattice energy in water. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so move to the answer of this question. So the answer is option number B. So for a compound to be soluble, the hydration energy must be greater than the lattice energy. And since NaCl is soluble in water but insoluble in benzene due to the following two reasons, that is del H of hydration is greater than del H of lattice energy in water and del H of hydration is less than del H of lattice energy in the benzene. That's why the option B is the correct answer. Okay. So moving to next question, that is question number 3. Which of the following compounds contains no covalent bonds? KCl, PH3, O2, B2H6, H2SO4. We have to select among them. So options are KCl, B2H6 and PH3, KCl, H2SO4, KCl, KCl, B2H6. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option number C. So KCl is the only ionic compound among them, and the covalent bonds in pH3, O2, B2H6, and H2SO4 are shown here in this diagram. This is pH3, this is O2, they have covalent bonds, and this is B2H6, they also have covalent bonds, and this is the sulfuric acid. So in sulfuric acid, all the bond between S and O, that is this double bond O, atoms are covalent bonds. So in the following manner, we can see that the covalent bonds in pH3, O2, B2H6, and SO4 are given here. KCl is the only ionic compound which is not having the covalent bonds, and hence the option C is the correct answer. Let's move on to the next question, that is question number 4. The percentage ionic character in CSCl bond present in CSCl molecule will be if the electronegativity values for CS and Cl are 0.8 and 3.0 respectively. Options are 62.9%, 60%, 75%, 52.14%. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option number D. So percentage ionic character will be equal to 16 times electronegativity of chlorine minus electronegativity of CS plus 3.5 times square of difference of electronegativity of chlorine and electronegativity of cesium. So putting the values in this formula, we get the final value here in the percentage is 52.14%. Hence option D is the correct answer. Moving to the next question, question number 5. Which one of the following molecule is polar? So options are XeF4, IF5, SbF5 or CF4. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so let's see. The correct answer is option number B. So only IF5 is polar because of its unsymmetrical structure. Rest of the molecules have zero dipole moment as they are symmetrical in nature. So this is the structure of IF5 and it is a polar molecule. Okay, so hence the option B is the correct answer. Moving on to the next question, question number 6. Which of the following pairs has zero dipole moment? Options are CH2, Cl2 and NF3, SiF4 and BF3, PCl3 and ClF, or BF3 and NF3. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option number B. So SiF4 is a symmetrical tetrahedral molecule and BF3 is a triangular planar that is symmetrical structure, and hence they have zero dipole moment. Hence the correct option is option number B. Let's move on to the next question. Question number 7. Bond distance in HF molecule is 9.17 into 10 to the power minus 11 meter. Dipole moment of HF is given as 6.104 into 10 to the power minus 30 centimeter. The percent ionic character in HF will be, the electron charge is given and the options are 61%, 38%, 35.5% or 41.6%. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option D. So percent ionic character formula is given by mu observed, that is dipole moment observed upon dipole moment calculated multiplied by 100 as we are calculating the percent ionic character. So mu calculated on interchanging these mu calculated is E cross D, where E is given in the question and D we know as it is given in the question bond distance. So on multiplying this, we get it in as 1.467 multiplied by 10 to the power minus 29 centimeter. And on putting the value of mu calculated in the formula of percent ionic character, the formula will be 6.104 multiplied by 10 to the power minus 30 upon 1.467 into 10 to the power minus 29 multiplied by 100. It is coming out as 41.6%. Hence, option D is the correct answer. So let's move on to the question number 8. Among the following, the maximum covalent character is shown by the compound. Options are FeCl2, SnCl2, AlCl3, or NgCl2. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option C. And the covalent character can be determined by applying the Fajan's rule. And in all the given compounds, an ion is same, that is chlorine. And hence, polarizing power is decided by the size and charge of the cation, as the anion is same. So Al3 positive, aluminium 3 positive with the maximum charge and smallest size has maximum polarizing power. Hence, AlCl3 has maximum covalent character. Hence, the option C is correct answer. Moving on to question number 9. The correct statement for the molecule CSI3 is: options are, it is a covalent molecule. It contains cesium positive and I3 negative ion. It contains cesium 3 positive and I negative ions. It contains cesium positive, I negative, and lattice I2 molecule. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option B. So I3 negative is an ion made up of I2 and I negative, so which has linear shape. And while Cs positive is an alkali metal cation. So the correct option is B option. Moving to question number 10. Bond order normally gives idea of stability of a molecular species. All the molecules H2, Li2 and V2 have same bond order, yet they are not equally stable. Their stability order is: options are H2 most stable, then V2, then Li2, H2, then Li2, then V2, Li2, then V2, then H2, and V2, then H2, then Li2. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option B. The molecular orbital configuration of the given species can be written as: for H2, the electron will be 2 and the electron configuration will be this. For Li2, electron is 6 and we can arrange the 6 electron and write the electronic configuration like this. V2 have 10 electrons and we can write the electronic configuration for the same like this. As the number of antibonding electrons, that is sigma star or pi star electrons, increases, energy increases and stability decreases. Thus, the correct order of stability is H2 the most, then Li2 and then V2. Hence, the option B is the correct answer. Moving on to question number 11. Which of the following compounds has the smallest bond angle in its molecule? Options are H2O, H2S, NH3 or SO2. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option B. Bond angle of H2S is smallest because S atom is larger in size and has low electronegativity. Hence, the option B is the correct answer. Let's move on to question number 12. Arrange the following molecules in the increasing order of the bond angle. So molecules are H2O, second molecule H2S, then H2SE, and then H2TE. Options are given as: fourth, the highest bond angle, then third, then second, then first. Then B is first, then second, then third, then fourth. C is fourth, then second, then third, and then first. And D is first, then third, then second, and then fourth. We have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option B. And lone pair bone pair repulsion is maximum in H2TE due to the least electronegativity of TE element and minimum in H2O due to high electronegativity of oxygen. So the correct order is most in first, then second molecule, then third molecule, and then fourth molecule. Hence option B is the correct answer. Moving on to question number 13. Consider the following iodides: Pi3, ASI3, and SPI3 having their bond angle respectively. The bond angle is maximum in Pi3, and which is due to small size of phosphorus, due to more bond pair repulsion in Pi3, due to less electronegativity of phosphorus, or none of the above. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option B. Since P is most electronegative among the given options, due to this, there is more bond pair repulsion. Hence, option B has given the correct reason. That's why option B is the correct answer. Moving on to question number 14. Bond energy of HH, FF, and HF bonds are 104, 38, and 135 calorie mole inverse, respectively. The resonance energy in the HF molecule will be. Options are 142 kilocalorie mole inverse, 66 kilocalorie mole inverse, 72.14 kilocalorie mole inverse, or 79.26 kilocalorie mole inverse. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option C. Resonance energy is given by del of HF will be equal to bond energy of HF minus under root bond energy of H2 multiplied by bond energy of F2. On putting the given values, we calculated the resonance energy for HF will be 72.14 kilocalorie mole inverse, which have asked in the question. So the correct answer will be option C. Moving on to question number 15. The species in which the N atom is in a state of sp hybridization is. Options are NO2 minus, NO3 minus, NO2, NO2 plus. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option D. So they are the species given in the options, and this is the hybridization state regarding related to the molecules given. So for NO2 minus, the hybridization is sp2. For NO3 minus, hybridization is sp2. For NO2, the hybridization is sp2, and for NO2 positive, the hybridization is sp. Hence, in the NO2 plus molecule or ionic molecule, the hybridization is sp. Hence, the correct option will be the D option. Okay, thank you.